The world of 3D art is splitting into two groups: artists who spend days doing everything manually, and artists who use technology to speed up their results. If you want to survive and scale your business as a modern designer, you need a smarter workflow. Today, I'm going to show you the exact strategies to integrate AI tools directly into your pipeline. Let's start with the single biggest bottleneck in 3D animation: render times. Historically, rendering a clean, high-resolution cinematic walkthrough meant locking up your computer for days. But think about what a video actually is. It's just a sequence of static images playing back quickly. And rendering 24 individual uncompressed frames for every single second of a video is an outdated way to work. Here's the first formula. Before you hit render in Blender, go to your output settings, switch your frame rate to custom, and set it exactly to 6 frames per second. Your render times will instantly drop by 75%. What used to take 4 hours now takes less than 1. Now your raw export from Blender is going to look incredibly choppy. Do not panic. We did this on purpose. We just created a lightweight, mathematically perfect blueprint for our AI tool. Next, we open Comfy UI or any other AI software that does frame interpolation. We import our choppy 6 FPS video into the system and pass it through a specialized node called frame interpolation. This model uses AI to analyze the pixels inside frame A and frame B, track the movement vectors, and generate the missing frames automatically. Because we have started with 6 frames, we set our interpolation steps value to exactly 4. 6 times 4 equals 24. The AI instantly generates 4 clean brand new frames for every single frame you render. Because the math locally happens on your computer, it takes seconds per frame. Look at the final result on the screen. The camera movement is perfectly fluid and the quality is entirely sharp. Now, if cutting your render times by 75% isn't enough, there's a second, even more extreme method. Think about what a standard camera animation actually is. It's just a camera moving from a starting position to an ending position. Here's how you bypass 99% of your render queue. Instead of rendering the full sequence, you only render 2 single images from Blender. You render your very first frame and your very last frame. That's it. Your total render time drops from hours to just a couple of minutes. Now you have a start and end frame, but no motion. To bridge the massive gap with flawless cinematic realism, we hand those 2 images over to an advanced video AI model like Kling. We open the interface and upload our first frame as the starting point and our last frame as the end. Then in the prompt box, write a highly precise description of our camera path. The AI analyzes the geometry of both images and builds the entire camera movement for us. Look at the final results on the screen. Because a model like Kling understands real-world physics, it doesn't just transition between the 2 frames. It injects a realistic camera weight, subtle micro-movements, a perfect lighting consistently. Whether you use frame interpolation to keep absolute control over your exact render path, or the first and the last frame hack for pure speed, you are winning the time war. The second major bottleneck in architectural visualization is environmental design. You can design the most luxurious interior room in the world, but if the view outside the window looks fake, the whole illusion wrecks instantly. In the past, finding the perfect high-resolution backdrop meant spending hours scrolling through a commercial stock website, and most of the time, you had to settle for a generic image that didn't quite match your scene's camera angle or perspective. But with modern generative models, you can create the exact background you need on demand. You don't hunt for assets, you describe them. By prompting for an 8K ultra-wide angle skyline or a clean landscape, you get a pristine, custom backplate in less than a minute. But we don't just use this image to fill the empty space behind the window. We use them to handle one of the hardest things to fake in 3D, glass reflections. When you place an 8K backplate outside your room, it interacts perfectly with your camera lens. As your camera pans, the glass in your windows and the glossy surfaces nearby catch sharp, mathematically accurate reflections of the digital world outside. It grounds your entire render in reality, making the interior feel like it belongs to a real breathing city. The third major bottleneck for any 3D designer is hunting for textures. We spend hours searching through a material libraries trying to find the exact fabric pattern or a wood grain we see in our heads. And even when you find a pattern you like, it's often too low resolution or doesn't tile seamlessly across a large surface. You end up wasting time fixing seams or settling for a texture that looks repetitive and cheap. Instead of searching for materials, you can now generate them using AI. Once you have your custom-based image, You can upscale it into a crisp 4K or 8K asset. Then you bring it into Blender and let your shader nodes extract the roughness and the normal data. The final layer of photorealism is always about imperfections. In the real world, nothing is perfectly clean or perfectly static. There is a micro texture on fabric, dust in the air, and subtle movement everywhere. This is where you use AI for the ultimate polish. We take our finished crisp 3D render and bring it into image-to-image workflow. Look at what happens when the workflow runs. The AI looks at our clean 3D base and injects reality into the pixels. It completes the illusion, turning a CG render into a photograph.